Alright, here with the rest of this, or with this video, we're going to talk about some just examples of transformations, how to write them using function notation. So we're going to do three things on these. Part A, we're going to identify the parent function. And then part B, we're going to describe the change. Actually put into words what's happening. So we're going to describe these transformations in words. And then we're going to graph them. We're going to actually sketch the graph. And then the last part is we're going to write in function notation G in terms of F. So write function notation of what's happened. Of that transformation. So let's get started, do a few and see how they go. Transformation. There we go. Alright, let's do this one. Let's start with g of x is equal to x minus 8 squared. And so what's going to happen is first identify the parent function. So the parent function is f of x is equal to x squared, the quadratic parent function, the parabola. And so kind of even can make a little note to myself. That's what it's going to look like. And then for part B, we want to describe the change. So how has f changed from g? So the first thing that I notice is this minus 8. And so that negative 8 means that the parent function has shifted 8 to the right, because change inside the function always moves opposite of which direction it looks like. So it's a minus 8, so it's movement to the right. Then part C, sketch the graph. So let's go over to our graph and sketch it. So I have my original parent function, right, which is just the quadratic. And so then we're going to shift this thing 8 units to the right. So instead of starting at 0, 0, I'm starting at let's count by twos, 2, 4, 6, 8, starting at 8, 0. And then from there, it's going to be the exact same parabola, just over 8 units. So my new function is there. Alright, so this is my, I think I'll even leave the other one. This one is f of x, that's my parent function. And this one is g of x, that's my transform function. Part D, describe the change in words, or describe the change using function notation. So g of x is equal to, well, how would I write that change? Well, that is inside the function, so that is f of x minus 8, because the function has an x minus 8 in it now. So instead of x squared, it's x minus 8 squared. And that would be the last part there. So that was a nice, simple, easy one to get us started. Let's move on to one that might be a little bit more intriguing. Let's do this one. Let's go to, same process, but let's do a new one. Let's do g of x is equal to negative x plus 10 squared plus 5. That'll be fun. Alright, so parent function is, oh, how nice, it's the same parent function, x squared. Change that has happened, well, there's 3 different changes. First thing I notice is the plus 5 out here, which means that it has shifted up 5. And this plus 10 on the inside reminds me of the negative 8 from the last time, so that means it's also shifted left 10, because it's opposite, negative shift. And then the last thing is this negative out in front, which will mean that it is reflected across the x-axis. Oops. Alright, so now on to part C. We're actually graph this thing. So I'm going to take my original function, right, my parent function, which would look like this again. There's my good old f of x. And I'm going to shift it 10 to the left. So let's count by 2's again. -2, -4, -6, -8, -10. 10 to the left, and up 5. 2, 4, 5. Again, count by 2s here. And so here is my new vertex, right? Because I've moved the vertex, which used to be at 0, 0, left 10, up 5. Then the last thing we said is it's reflected. So instead of opening up like this, that thing is going to be going down and reflected across the x-axis to where we're going down that way. So it opens downward instead of opening up, and that is my g of x. And so I have my transformed function. And then lastly, write this in function notation. So g of x is equal to, and let's talk about all the changes we need to account for. Well, that's f of x plus 10, right, because it moved to the left 10, plus 5, because it moved up 5, and then a negative f of x, because it is reflected, it's flipped. And so I've got that negative f of x there, plus 10. So I now have my function notation of it as well. Alright, I think we got time for one more. There are so many good problems in there. I wish we could do them all, but we just don't have time. So going back to these, let's do one more, and let's do a square root function. So let's say that g of x is square root of 3x plus 1. So what is my parent function? Well, parent function with a square root function like that is pretty easy to pick out. It's square root of x. Transformations that have happened. Well, the transformations are it has moved, shifted up 1. That's good to see, a vertical shift of 1, so shifted up 1. And then how's that 3 going to affect it? Well, inside is horizontal, and that is a horizontal shrink. It's actually going to make my square root function happen faster. It's shrinking it in horizontally. So now we need to graph this thing. So my original function, 0, 0, 1, 1, right? If I plug in a 4, I'd get a 2. So I have this horizontal out here like this. 9, 5, 6, 7, 8, 9 would get me up here to 3, right? And so I have this square root function like a half of a parabola on its side right there. That is my f of x. Now, it's moved up 1. So first thing I can say is that I'm definitely going to move up to here, to where I'm at 0, 1. But then it's a horizontal shrink, so it's moving it in. So if I think about it, if I were to plug in, say, a 3 in for x, so 1, 2, 3, well, 3 times 3, the square root of that is 3. And then the plus 1 would move it up to 4. And so this entire function, f of x, that I have out here is 9. That was where I made it to 3. Now my entire function has been compressed to where it happens by the time I get to 3. So this horizontal shrinking motion has made it to where the entire thing now happens right here, and it will still take off like a square root function, but so much more shrinking, so much faster, so much, I guess I should say slower, because at 1/3 I'm up at 1. Plus 1, which would be 2. At 4/3, right, I would be at 2 right there. And so this thing is just really compressed to where it looks so much more like that. And that is my g of x. And so that horizontal shrinking has taken the whole thing and compressed it down much smaller. If we were to draw it on the exact same graph, it would look like to where it was like right in here, really, really small, right? But then it's also moved up 1. So then my final thing, D, writing g of x in terms of f. So g of x is equal to f of, well, what's the change? It's f of 3x plus 1, because there's that plus 1 on the outside. And so that's an interesting square root function. Horizontal shrinking and horizontal stretching, I think, are some of the hardest ones to wrap our minds around of what's happening. But that is a really good problem there. It's 42 out of the book, but interesting problem there. Okay? All right. Till next time.